All right, so today we have Ken Liu. He is a PhD student in computer science at Stanford, and he just wrote an excellent new post, which I am linking to in the episode notes, called Machine Unlearning in 2024. So, Ken, welcome to the Data Exchange podcast.
Thank you, Ben. Thanks for having me.
So, before we get into the details of what unlearning is, I guess I'll start out with what inspired you to write about unlearning,
Yeah,
and why now? Why is now the right time to write about unlearning?
yeah. So I started thinking about unlearning, I think, last year, a bit later in the last year, I think early. I'm not quite sure about the time. Um, and I think last quarter I was working on a learning project with Percy. I think it's such a fascinating area, and we are starting to get these large models, and then people are starting to kind of have this renewed interest in unlearning. So before then, I was thinking more in terms of the privacy perspective, but since I'm starting to work on large models these days, I think that there are many, many new areas that come up and new problems that come up. And I think that as I read more and realize this is actually a very, very broad topic and there's a lot of unsolved problems. And we're also starting to see a lot of new progress in the last couple months. And so all of these things combined kind of led to this writing where I just want to kind of summarize what I've learned about and then kind of, give it to everybody in a very easy to understand format.
So, all right, so let's dive in. So, for our listeners who don't follow this topic closely, um, so can you explain machine unlearning in simple terms, and how does it differ from the learning process we typically associate with AI and machine learning?
Yeah, so machine learning, I think at the end of the day, is just about removing, influences of certain training data points, right? And so when you train a bunch of data into the training model, into some machine learning model, it's kind of natural to some extent that you want to think about the opposite, where you can remove certain things. This removal part is, I think, very, very vague and broadly described. Like, what do we mean by removing a particular piece of data point, and then a particular piece of training data? And what happens if this training data has influences on other training data and influences on the model behavior? And so being broadly defined, I think unlearning in order to work on it, you need to think about particular applications. Like, do we want to unlearn a particular training example? Suppose it's like a face classifier. Someone's face is in that training model. Do you want to unlearn that face? Or is it like a large language model where you train on a bunch of New York Times articles and you want to remove those from your training data so that you don't get sued for copyright? And so different applications kind of call for different metrics and different definitions. But yeah, at its core, it's just about producing a model from a base model, producing an unlearned model such that it would behave as if we haven't trained on that piece of forget data, which by itself can be very hard to specify.
Right. So historically, can obviously now that we're in the generative AI and LLMs, it seems obvious that this is useful, right? So, but obvious. So from what you're saying though, this field of unlearning existed long before LLMs and generative AI, right?
Yes, yes. So it started off, I think, in 2015. That was the first paper when that was published. I think someone on Twitter pointed out that there are papers back in 1990s. That was before when I was born. That people started thinking about this idea of decremental learning, where you have certain data points you want to, decrement, I don't know, from the training data. So that part I think there's a bit of history there, which I didn't touch on really in the blog post. But I think like since deep learning, 2015 is the time. And there, people was looking mostly at examples. So I know these are the training examples, these are the forget examples, and these are retained examples. I wanted to make sure that the model doesn't, behave that well on these forget examples. I think it was proposed to some extent in response to right to be forgotten. So this is a law passed by the European Union from, I think, 2014. and which basically says a user has a right to remove themselves from to request removal of themselves from a service provider. And that concept when proposed wasn't really having the idea of machine learning in mind. And only later on people realize that these service providers train your data into this model, and this model is something that's big, that is that we can't really interpret. It's like a giant hodgepodge. That was a word I used in the blog post. And we don't really interpret this. We can't really separate this, right? And that kind of spawned the research, I think from there. And then people started thinking about whether you can train a model to be kind of like private in the first place, so that there's nothing to unlearn. So the intuition there is, if you train your data with certain guarantees, whether that's privacy or robustness guarantees, then these models don't really kind of overfit to any particular data point. And hence, when you kind of like request unlearning on those data points, there's really nothing you need to do per se, because I show to you that these models haven't really learned these data points. So there's that kind of development there as well. And then to the LLMs come along, ChatGPT came along. I think it becomes different again. So yeah, so also back to the first question, I think.
So before we dive into kind of the different popular approaches to do unlearning,
Mhm.
so listeners might say, I don't need to do unlearning because I can just do retrieval augmented generation, which is something you address in your article. So explain to our listeners why RAG solves some things, but not everything.
Yeah, so I think, to be honest, even now we're not really sure if RAG is completely there yet in terms of both utility and its ability to replace unlearning. So it's kind of both sides here.
Yeah.
So we know RAG works, but we don't know if it can replace fine tuning just yet. So there are certain
Right.
things you want to fine tune in the model, things like human preferences, and then among other stuff. On the other side, there hasn't really been a baseline, to be honest, that compares uh, RAG-based approaches to like a fine-tuned baseline. Okay, let me take that back. What I mean by that is, like, there hasn't been a systematic study of like comparing unlearning methods that you apply to a model compared to a model where you don't have those data points and you retrieve them, right? So part of the issue there is we when we think about unlearning, we need to think about what data you want to remove. And you want to think about this base model that never had those data in the first place, right? These days, we don't really get them. And we get a bunch of LLMs that are trained on almost everything, and we don't often know what they are trained on. And so establishing a true kind of ground truth model that doesn't have something is kind of hard, right? So without that baseline, it makes it so that you can't run the comparison very nicely. And no one, I think there's some work that touches on, I think that is Min et al. Touches on using, putting some sensitive data on the side and try to do some retrieval. I think that's a very good first step, but I think we need more work comparing those. I guess back to,
And Ken, I guess the intuition is, so for example, so with RAG, right? So I have a prompt and then it hits the data sources. Data sources come back. But then I guess the problem there is the foundation model or LLM may actually overwrite the retrieved data sources, right? Because if it has prior knowledge, it might say, "Okay, that's great, you retrieved those, but I actually know more. I know something about that topic. Let me formulate an answer," right? So
yeah, that's also a very good point. So
yeah.
because we don't know what the LM knows, when you retrieve something, it could just be an elicitation, right? We're eliciting what the model already knows rather than asking the model to reason in context about what you just retrieved. So there's that issue. I think, yeah, exactly. The general issue is just we don't really know what the model knows, and we don't have ground truth of it not knowing certain things. There are other issues with RAG, I think, in general. There's the problem where what if you have these idea of just lots of things you might request unlearning from, right? So imagine you are OpenAI, you put out ChatGPT, and then you open this portal that allows people to submit these requests. People can submit like almost any random thing, right? And if you were to think about, okay, all these are things that could possibly receive a request, I'm going to put them on the rack. I think that would be a sizable chunk of the pre-training set, and that would, to some extent, if you remove them, that will harm the model's utility, right? So that's a problem. So the space of unlearnable things is pretty big. And then there's also the problem of should you always dump sensitive stuff? Because the stuff that you may receive on learning requests may be sensitive, and should you dump them into the context is another question, right? By dumping them in context, you're trading off the model regurgitating them versus opening up new attack surfaces that try to steal things from context. So people have done that believe on Twitter, stealing system prompts, stealing like the, whatever the model is prompted to do. Jailbreaking techniques that tend to apply here. Yeah. So I think these are the main issues. Yeah.
So let's go, Ken, let's go to the what you consider the popular approaches for doing unlearning. So if you were to kind of tell our listeners, like, what are some of the top 2 or 3 ways people are doing unlearning today, particularly in the context of LLMs and generative AI?
Yeah, I think these days I would maybe oversimplify and try to say that most methods kind of fall back to this category of training to unlearn or learning to unlearn. Essentially, what we are doing these days with LLMs is that we're still, making the model learn something. It's just that this something is of a different direction. So,
wait, before you continue, so I guess we assume I have access to a pre-trained model, right?
yes,
So let's say I have access to Llama 370 billion, and then I do some fine tuning, because basically, what's the point, right? So I'm going to fine tune. I'm probably most likely fine tuned Llama 370 billion. And then what? What do I do to do the unlearning?
yeah. So we can go through some simple examples
Yeah.
that people do these days.
Yeah.
Suppose you want to forget, what's a good example here? Maybe something easy like some car accident that happened in Palo Alto, last
Mhm.
week. You would go on and collect examples of that thing that you want to forget, this news article. So that would mean these sequences in that article, and its quotations, and like other rewritings or paraphrasings of them on the internet. So you go on and collect like what we call a forget set, and you go on and take this forget set. You would, for a pass, you get a gradient, and then you go uphill, gradient ascent instead of descent on these examples. So that's one of the most trivial ways simplest ways to run unlearning. And people started exploring other more complicated things, such as you take these forget examples and you take some retain examples and you try to do preference learning on them. So instead of saying, well, this is a forget example that you that we saw, we're going to create, like, say, some other examples, or even the counterfactual of the forget example that you collected, and then we're just gonna teach them that I prefer this version of that example as opposed to that version.
So now,
Or
so Ken, stop here for a second. So
Mhm,
in the case of fine tuning, right? So if I'm a developer,
mhm,
I'm not too savvy. I'm not too advanced in my knowledge of machine learning.
mhm.
There are services now online where I can do fine tuning, right? So fine
Yeah,
tuning endpoints and stuff. So everything you've described so far doesn't exist, right? So you have to belong to a much more advanced group to do this, right?
yeah. I think technically it's almost there, because the simplest way to do this is basically flip the sign of those gradients. So if the fine-tuning service provider allows you to specify that would be great. But to my understanding, I think the fine-tuning service provider only give you space to, like provide these examples. They
Yeah.
abstract away the hyperparameters, like how they implement the descent and stuff like that. So yeah,
Yeah,
yeah.
fine tuning now is basically focus on your data, fine tuning data. That's it.
Yeah, yeah,
Yeah.
yeah. So unlearning algorithm basically makes some simple changes to how you fine tune. At the end of the day, you're trying to get some signal from these forget
Can
examples, and you're
can,
just
can
applying them
you
in different
Ken,
ways.
can you hack the fine tuning services by saying, so here are some examples. of non-responses, or you create a fine-tuning data set to do the unlearning. Is that?
Yeah. Basically, yes. At the end of the day, you should go on and collect some form of data to represent the data that you want to unlearn. In fact, this is one of the challenges with LLMs too, because people would say, well, please forget this or please forget that. But what do we mean by forget that? Let's say forget US President is Biden. You're gonna go on and there's so many texts out there, references out there, or quotations or paraphrasings out there that refer back to the fact that US President is Biden. So you could go on and try to collect a lot of examples, but there's still like a little gap between what you collect and what is really learned by the model. It's kind of like a fact that the model has learned. And so depending
Now, Ken, there's also the possibility of, I think that what people in the unlearning space call just ask for unlearning,
Mhm.
which basically is in the prompt itself, right? So when you prompt, you go, okay, so here's my question. If it mentions Biden, don't uh, don't return a response that mentions Biden or this topic. So you can basically put the request to unlearn in the prompt itself. Is that a viable strategy?
Yeah. I think people are trying that. Whether that's viable, it's very interesting and debatable. The reason for that is right now we're at a point where people are thinking that both prompting and fine-tuning are equally valid ways to guide a model's behavior. In either case, like we don't have guarantees, right? Even with fine-tuning based on learning, we are really just heuristically applying some gradients to the model and hope that the models, take these gradients and behave in the right way.
So
Prompting,
here's a hack,
uh-huh.
or well, in the prompting, right? So I would prompt my way to unlearn, but then before I return the response, I pass it to another LLM to reinforce the unlearn request.
Yeah, yeah. In fact, I wrote about this in I think section 2.5 of the blog post, which
Yeah,
basically says you could, in principle, design
a
like a
pipeline.
yeah, like a pipeline,
Yeah.
like a complex LLM system, where different LLMs play different roles in rewriting, in answering that question. So
Yeah.
first, detect whether this question is relating to the thing you want to unlearn, and then the second thing, like rewrites it only if needed, and then the third thing does the filtering, and I mean the fourth thing checks the input, like rewrites the input to prevent like a prompt injection or something. You could in principle do that. I think someone should build that. I think it would be really cool to see that system work on the LLM benchmark, the unlearning benchmarks right now that we have right now.
So right now, the techniques available to people that are doable is this one that you just mentioned, right? So, and then the rest that are involve some algorithmic, like you said, gradient ascent sort of things. Either you hope that some endpoint provider makes that available down the road, or right now it's basically an advanced topic that teams with much more skilled people uh, can do, right? So, and then on the other hand, I guess the problem is you have no control over the pre-trained model, right? So pre-trained models already pre-trained. You can't do things like data replacement or data pruning from because it's already been pre-trained. Yes, so you're just so I'm kind of trying to think through solutions for an audience that's mostly applied people that are not necessarily building models themselves. They're either fine-tuning or RAG is
Yeah.
what. Yeah.
Yeah, I think you mentioned 2 points here. One is about, um, in the future, can we have such a service that offer to practitioners? Are we there yet? And second thing is is about pre-training unlearning versus fine-tuning unlearning, in the sense that you have different data from different sources. For the first point, I think that, to be honest, I also should clarify gradient ascent is only one of the methods.
Mhm.
Even accounting for the different methods that we have, we're really not getting to the place where they work really, really well. They kind of work. Like if you apply them, whether that's like some form of a DPO objective or some form of a representation steering, activation steering objective, they kind of work, but there's no guarantee. Like if you ship it, someone will break it. And so because of that, I think there's still a lot of risk for any model provider just to ship that service. It's like you ship it, but you have to also have this disclaimer that says, well, I mean,
Right.
like it could break any time, at any point, which is what is right now. And to the second question or the second part, which is about pre-training data versus fine-tuning data, I think that pre-training, unlearning things from pre-training is much harder, just because of the sheer scale of the model and data set. Like for the same piece of data that you have seen, we really don't have any idea how many other places that this piece of data has appeared, right? So let's say it's like a Reddit post. It could be that this model provider decides to repeat the Reddit portion of the data set 10 times. And so you memorize it really well. And it repeated it in different formats, like one in Markdown, the other in HTML, the other in, I don't know, whatever like that they do. And second thing is people don't really go through the pre-training data set these days to some extent. These, like, for example, Llama 3 is trained on 15 trillion tokens. That's a lot of tokens to manually inspect. So it's too complicated to kind of to understand the interconnections between data points. That makes it so that if you go on and try to unlearn something, there almost I would believe that there would always be a new angle for you to kind of like elicit that knowledge from the model, right? So you can maybe
And Ken,
ask it.
there's also the question of how adaptable these techniques are in the following sense, right? Yes, so for example, in the area of preference alignment, people are doing things like reinforcement learning with human feedback because, supervised fine-tuning works, but kind of it's not very adaptable once you get past the kind of the area where you have great fine-tuning data set, then it may not work, right? So in the case of unlearning, right? So let's say you can do a good job unlearning a concept, but then you find yourself, hey, there's other concepts that I should probably unlearn as well. And it's a dynamic list, right? So it's constantly evolving. And so whatever you do, whatever technique you settle on has to be something that's fairly performant, not too expensive, because you might constantly have to unlearn things, right?
Yeah.
Whatever. So actually that pipeline idea that you described might be the most uh practical in some ways, because I mean, if there's a new concept, then it might not be that hard to build this pipeline.
Yeah, because this pipeline is you can do fast iteration on it, right? And if you bet on the idea that this model is going to get stronger, they can interpret your prompts better. Then that kind of means that it's probably better to do fine tuning to do the prompting technique route as well. I think at the end of the day, it kind of falls back to two things, right? I think I mentioned that in the blog post, which is that is fine tuning or prompting better at steering the model behavior? Because right now, none of them have guarantees. If one of them steers better, like if you can use the gradient from those forget examples better, you should do fine tuning. But at the same time, if you can also rely on the model itself to do the reasoning on the fly to kind of correct itself when it tries to answer something that's related to the thing that you want to unlearn, right? Suppose you ask it about, what is the color of the car of Joe Biden's wife, right? So that's like a multi-hop reasoning thing. You can ask the model that question, and then you could do something like chain of thought where the model would like answer, and then it reads like, oh, actually, the color of the car of the Joe Biden's wife is Joe Biden's car. And then like that color, we knew it was before. And then because he asked me to unlearn US president, so I shouldn't answer that question. And so like you would self-correct. You could imagine systems where the model first do this kind of chain of thought layout of those reasoning, and then have a different model that looks at this reasoning and see whether like it's trying to review something that you're trying to unlearn. And that sounds very interesting to me. The core essence of that is that you're relying, because the unlearning scope is so big, it could be so big, as you said, concept after concept and concept kind of merge each other.
And changing, right, over time. Yeah.
And changing. So we're essentially relying on the inference capability and reasoning capability of the model to kind of correct and infer on the fly. Much like how humans behave too. If you think about, suppose I said I unlearned something, I would first say certain words about it, and then I suddenly realize, oh, actually I know about that thing, and I want to pretend that I have unlearned it. So I would then stop myself from there and not say anything else about that topic.
Which brings me to another topic, which is generally hard to answer in most of generative AI, because it depends on the use case and your application, which is evaluation, right? So how do I know I've unlearned enough so I can deploy?
Yeah, I think this is one of the biggest broken things about unlearning right now, that I think I want to applaud like all the work that's come this year in building the benchmarks about unlearning, because we really don't have them before. There was a work last year on unlearning Harry Potter text, like references to Harry Potter, and like we want to produce a model that doesn't pretend not to know Harry Potter. There was no benchmark on that, so the way they did evaluations was kind of ad hoc. They show you how the token probabilities have changed. They show you a set of like trivia questions and show that the model doesn't answer them. But that wasn't really particularly satisfying, right? Like, how do we actually know?
Yeah,
The question we get,
especially for people building applications, right? So where the stakes are higher than just some
exactly.
benchmark, they need some kind of evaluation metric to know, okay, I've done enough. I can move forward, right? So
Yeah. Which is why I think we need to start having application-oriented benchmarks. So when you do unlearning, you definitely have some application in mind, whether that's like for privacy, we don't want to misclassify this person anymore, or like we want to classify this person anymore, or we want to.
and Ken, one other thing I want to kind of highlight is, you can unlearn something for an internal app, internal meaning within your company, and there's bad things can happen there. Like I may see something that I'm not supposed to see, right? So, but more serious is having to unlearn something for an external facing app that your customers uh, interact with, right? So there, the stakes are even higher. So the evaluation criteria may even be much more strict, right?
Exactly. So when you perform unlearning, it's really important to specify what the application you have in mind is, and then what is the success for that application in particular. So, for example, if I take the WMDP benchmark that's proposed recently, it has a bunch of questions on biosecurity, cybersecurity, and chemical security. And so there, the metric there is that if the model can't answer those questions, then it's deemed safe, right? It says nothing about, for example, how the model predicts the perplexity of the model on those dangerous texts, or it says nothing about like how close is this model compared to a model that was never trained on these dangerous knowledge. So those metrics, like perplexity-based metrics or closest proximity metrics, may matter for other things that you care. But in this case, since you only care about the model's ability to, hack a website or like make a bomb or something, then you go on and like devise these questions to test it. Similarly, in practice, again, like we need to think hard about what you really want. Like, why do you want to apply unlearning in the first place? And there should be a metric for that there. And also at the end, I also want to just emphasize that because there's no guarantees, it should be kind of like put out in the clear that even though these metrics to some extent measure unlearning, there will be like attack surfaces that might, elicit whatever it knew before, such as asking in French or asking in Chinese about the same thing, that you suddenly knows how to talk about it. So the lack of guarantees makes kind of evaluating hard, and application specific, like push it towards like your use case.
Now the people who are building the pre-trained models, they're doing obviously they're doing red teaming, they're doing safety checks and things like that. So there might be a few things that you may not have to unlearn because they've already put some initial guardrails, right? But we're talking mostly about situations where it's much more domain specific or specific to your application, and you have to do it yourself. So
Yeah.
the challenge is actually doing it and knowing when you've actually done enough, right?
Yeah. To some extent, this is like scientists are offloading the challenge of defining unlearning and measuring unlearning to the practitioner, because we don't, to be honest, we don't really know how to measure it. And so if you want to apply certain unlearning algorithms, you should be clear that if you apply them, you should measure it against your own metrics. Exactly as you say. So that's kind of a broken area. We're hoping that as we move, there's lots of research happening right now in unlearning. So maybe there will be new definitions that will be more universal to practitioners. We don't know. We just don't know at this point. But I personally think that application oriented metrics are very important.
So in the course of your investigation of the unlearning, the landscape of unlearning, Ken, so is your impression unlearning mostly something researchers think about, or are you starting to hear or come across schemes in companies who are interested in unlearning and kind of developing tools and techniques?
Yeah, I think there's definitely growing interest, both from academia, like different labs at different universities, and certain institutions. And I believe government is starting to the public sector is starting having some interest in this idea as well. I believe
What about companies?
companies, I'm not too sure yet, because right now we're at a stage where people are rapidly building, and to be honest, privacy hasn't become a priority to a lot of companies. And in that sense, they would rather ship a new feature than to provide this button that says, okay, you can now unlearn yourself. There's an incentive mismatch, I would say, for unlearning and like companies serving big models, because companies want to have more data. They want to retain control. And unless it's mandated by law, which is generally a privacy, which is this by the way generally applies to privacy in general, like when all sorts of
Yeah, I
privacy
mean,
techniques.
if it take nowadays, of course, the main change, Ken, is it's much easier to build AI-backed applications, right? So if it takes you 1 week to build your AI app, and now someone tells you, hey, you need to take another 10 weeks to unlearn.
Yeah, yeah. We're hoping that unlearning it will be faster than training, because if it's slower than training, you would just retrain without the data points, right? I think the main issue here has still been that it's just there's not enough pressure or not enough incentives for companies to do this, right? So why would I unlearn you? Why would I give you this option to start with? No one's suing me. The government isn't like proposing a law, and like I really don't have to, as a company, I really don't have to provide this service. Now, I think it's interesting also to think about whether government should incorporate unlearning as a mandate, because of the lack of guarantees that it has right now. Like it's really a heuristic change to the model. Like
Well, what would the mandate be? So, I mean, because it seems like there's some, I guess it would be the equivalent of the right to be forgotten. That's the mandate, because who gets to decide what's someone has to unlearn, right? So
exactly. So if there is a mandate, it will probably look something like right we forgotten, but with like considerations with machine learning in mind. One idea that could make sense is that it would mandate the satisfaction of these unlearning requests, but over a period. So let's say I mandate now that companies have to start collecting unlearning requests, but they have to satisfy it within a year, because I want to account for the fact that users do want to unlearn, and then these models are really expensive. So I give you a year to do it, but you should do it. So something like that, periodic retraining. Otherwise, it's really hard to place a mandate using something that is not very mature yet. Like we don't,
right.
to be honest, like this is still in very, very active development, no guarantees whatsoever. Yeah. So I don't think it should be baked in policy as of now. Apart from like simpler solutions or economic solutions like retraining, and it's somehow distribute the cost among different parties.
So as we mentioned, at the beginning of the episode, there's many reasons to do unlearning, right? So there's copyright protection, safety, security, and then privacy. So in the area of privacy specifically, Ken, obviously there's a whole set of people who are doing privacy preserving machine learning, right? So that could range from federated learning, homomorphic encryption, secure multi-party computation, differential privacy. So what's the overlap intersection between that community and the people doing unlearning? Are they talking to each other? Is there reason to believe that those techniques that I just mentioned can be useful, at least for the privacy aspect of unlearning?
Yeah, I definitely think they are connected and people are talking. And to that point, I was working on differential privacy and federated learning for a while. And I just recently think more broadly about ML privacy and kind of got into unlearning a little bit and realized that this is way broader. But I think unlearning has a strong roots, as we discussed earlier, in privacy. And in fact, one of the ways to implement unlearning is to do private training. If you train things privately, then you don't have to unlearn. One challenge, however, between unlearning and other, these set of techniques is that techniques like differential privacy and federated learning kind of have let's just say they have different applicability in the modern age of large models. For example, training models, super large models with differential privacy will have a lot of system constraints. You're gonna have to, you know, have huge GPU memory because you gotta have these, for example, gradients, and then you're gonna slow down training. You're gonna have like bad utility, which people don't want, companies don't want. And then things like federated learning, they work really well for small models and for platform owners like Google and Apple. But we have not yet seen a feasible way to train something like a foundation model using federated learning. We won't be able to send these things like 7 billion parameters all over the place. It will take like a day to download on a crappy phone. And so because of the changing landscape of machine learning itself, um, I think some of these techniques don't apply as much as before. And so unlearning being like broader
And
concept.
also can now I guess there's a group of people doing the pre-training, right? So the people building the foundation models. But most people actually come after the fact, right? So they're either going to do fine tuning or RAG or something. So for the people who come after the fact, uh, do any of these techniques apply? I mean, there's the people who do the pre-training model or the models, right? So the llamas of the world, Claude, Gemini, GPT. But most of the world is really in the after the fact.
Exactly.
Yeah.
And part of the reason for the after the fact part is precisely because applying these things to the pre-training stage doesn't work that well anymore. Now you could apply, for example, private training to fine tuning. That works. We know that works. But the thing is, the guarantee that you provide, first of all, doesn't extend to any pre-training data, and you may still like get some requests on unlearning for pre-training data. And second, even if it applies for pre-training data for fine-tuning data, it could be that it doesn't really apply for fine-tuning data as well. Like let's say take the differential privacy to be more specific. There could be different versions of the fine-tuning data that already exist in the pre-training set. So when you fine-tune privately, how do you know that these pieces of data have not appeared? And does your privacy guarantee still hold if they have appeared already in the pre-training set? So
Or in the equivalent of the database world, right? Or just data security world, the equivalent of access control, right? So maybe the model can answer questions for you, but I'm not allowed to get those answers because I have less my access control is less. So do you envision a future where that might be possible, or that's too ambitious at this point?
So access control in the sense of there's certain data that
That you're privileged to, but I'm not, right? So
hmm, that's an interesting concept. I think the way we build these models right now, it's kind of hard to enforce access control because
yeah.
of the the prevalence of jailbreaking. Like technically, what the way you would implement access control is that we have trained all these
Or
systems.
you would have to, there has to be some sort of routing model where, okay, so
Exactly.
Ken asks the question, we go to this model. Ben asks the question, we go to this unlearned model.
Yeah. That's interesting, but that would also create like a
Too many
lots
models.
of too many models because precisely because there's so many things you could possibly unlearn, right?
Yeah.
I would say never underestimate the things that people would request on these models. Yeah, and in that sense, it like the way we do like access control really these days are just post-training guardrails, right? Like with some form of RHF that refuses to answer a question, some form of content filters that says, well, if you said this, I'm gonna let this through. Um, this goes back to the idea of building unlearning systems based on that principle, just like post-training guardrails. I'm gonna just have the model pretend not to know this thing, and because we have shipped these systems already for many other purposes, like being able to produce harmless responses, being able to not reference celebrity. For example, if you ask DALL-E, you won't be able to, you won't draw your pictures of a celebrity, for example. So because we have shipped these systems already for these purposes, it could, it's imaginable that we do this same thing for unlearning as well. We start collecting these requests and then just implement it like a guardrail around it.
So for the people who do pre-train the models, I think they may end up, I would suspect, Ken, that one of the things that will happen is more the data pruning scenario, meaning if New York Times wins its lawsuit against OpenAI, then OpenAI will need to prune New York Times data from the next version of the model, right?
Yeah, I think that would be very unlikely. Like even if OpenAI, sorry, yeah, New York Times wins, it'll be a very unlikely outcome. They might just achieve, agree on some financial
Yeah, yeah, yeah,
compensation.
yeah.
The reason for that is it's just in general very hard to remove things from the pre-training set, and you remove it cleanly because like every data point can have different versions of it in the pre-training set because pre-training set is so large. And this kind of connects to the data contamination community. Like people have shown that certain models you could like inject paraphrasings of the evaluation data set and then have it pass all the contamination checks of the model developer and then still manage to contaminate the model with the evaluation examples. So just the idea of paraphrasings and multi-hop kind of connections between entities makes it so that it's very hard to remove. And
So looking ahead, Ken, so how do you see the field of unlearning evolving, let's say in the next 12 to 24 months in terms of what's your sense of what are people prioritizing?
hmm,
Uh,
I think there will be a lot of benchmarks coming out for sure because as we were saying, it's just it's as we're still actively thinking about definitions, applications, and benchmarks and ways to evaluate this unlearning, and we don't have enough of that right now. So benchmarks, there'll be more benchmarks, and then I think people will start to think more about different techniques, probably like more principal techniques. Maybe it's worth visiting things like exact unlearning, where you have different components of a model responsible for different data. So now you don't have to worry about all the, messiness of the idea that this has no proof, that this is all heuristical. I can just delete that model component. So modular architectures are something that's interesting. I think definitely will happen. And people might start also exploring, like revisit maybe private training and robust training in general. So maybe you could imagine that there's a new way to pre-train a model that doesn't hurt the utility as much as differential privacy, but however gives a similar robust guarantee such that that the model doesn't overfit to any particular training sequence. And then you would definitely see people trying the guardrails and like have guardrails and then try them on these unlearning benchmarks. Um, Yeah, I think it's a very active space, so I'll try not to.
What do you think, Ken, is the timeline for, how fine, like I said, fine tuning now is basically a solved problem for developers,
Uh-huh.
right? So, because there's many services that you can do where you just focus on creating a fine tuning data set. So, what's the timeline for that being the case for unlearning, where it becomes largely I guess to a certain extent solved, right? So solved in the sense that you can do some amount of unlearning, uh, and there's services out there, proliferation of services where you can do some notion of unlearning.
Yeah. I think that would tie to application, as I was saying. So there has to be an application where people really want this, right?
Mhm.
So think about maybe thinking in
Oh, I
terms of,
mean, look, I mean, there's we laid out all sorts of reasons why this is important, right? So I think
that's
if
true.
you make it available, people, if it's, if you build it, they will come kind of scenario.
Yeah. I think that's great, but it's not like people would want it if it's not built. So for example, we could
But
definitely imagine a case where, for example, if OpenAI gives you this button, you can now
yeah,
forget me. People would click on it for sure.
yeah.
But people are happy chatting with ChatGPT all day long and have their chat histories trained on. So like people, like the people's tolerance of privacy is very fluid. I think that's the issue. And so let's say by saying privacy, I already like imply that this is like a privacy related application. Um, it's just that we haven't seen like application where we really have a strong demand for people to unlearn things. Maybe for copyrighted work there is,
Yeah.
but for a copyrighted work there will be other solutions
or
that
or
might be
or,
more
or company
practical.
company data, right? So
Yeah,
let's say you fine tune a model and then attach it to RAG, and you have this complicated mixture of experts, right? So, but then at some point you want to have some sort of unlearning module, so that just additional checks, so that maybe you have some valuable IP you want to make sure doesn't uh, get to be part of any response, right? So.
yeah. So you could imagine applications like that, and then you will like ship features that are particularly those to those applications. Um, Um, just thinking more broadly on the consumer side, like I think it's a very interesting question to think about what kind of applications would people want. But for the enterprise, for sure, like there this people would is gonna want stuff like that. Um, but people could also for enterprise, they could also just uh refine tune these models because these company data they're probably not part of the pre-training anyways. And then fine tuning these days are cheap enough that if you let's say wanna do unlearning only once in a month, then you can also afford to fine tune once a month, right? So I would just not go through all the messiness of having a tune model, having a flaky guarantee of unlearning, as opposed to I just re-fine tune it in the first place.
Well, you'll need some sort of uh, process or evaluation tool so that you can say, okay, so I've successfully unlearned.
Yeah.
Right.
So if you want to do unlearning, all the messiness of unlearning kind of comes with you. The
Right.
evaluation,
Yeah.
the lack of guarantees, and the and the algorithms don't really work that well these days. As opposed to if you know there's a alternative, like an economic or like a alternative, like some other form of some other mechanisms that allow you to achieve the same goal, but without the unlearning, I think people would do that as opposed to unlearning. So there hasn't been a very compelling case where unlearning is the only solution to the problem. Um, Now there could be like if we later on train these models in a very modular way, then unlearning can be the fastest, the cleanest, and the best method out there. It's just right now I think about unlearning as just another tool in the box where you can pick your tools, and it's not compelling and appealing yet to pick that tool in many of the cases that I can think of.
So in closing, Ken, so is the techniques that that you like or seem effective, are they ones that if I'm the one responsible for implementing this in a company, can I go explain it to someone, this is what we did, and you can see, you can see that we did it right, and so how are they inherently interpretable or explainable or
No, not there are different ways you can implement unlearning. If
yeah,
you do it through like modular architectures and you do some form of model merging at the end, then that's interpretable, right? Because all the data that I care is in this model. I know it's
yeah.
in the model. I can show you. I can show you the code. I can show you the logs and stuff like that. And then I now,
It can be audited, right?
yeah, and I can just remove this model from the pipeline. But if you do unlearning techniques that are more heuristic, which is I think a lot of the LLMs techniques are these days, they fine tune these forget examples in one way or another, like KL divergence and the gradient ascent, then there's no guarantee. It's all like a black magic. Like we hope the model takes these forget examples and learn that they shouldn't interact with those examples. But there's no guarantee at all. And in fact, even if I get a really unlearning algorithm, like on all the metrics that I devise for my application, it just works. I still really can't prove that I've done unlearning, right? There's the idea that different data sets can lead to the same model. So how can I formally show to you that this example was never part of it? Because it could be part of it, part of the training data set, and somehow the model decides not to memorize it. The deep learning part is pretty uninterpretable. And that makes it so that we can't really, prove unlearning. Only you can only like show that it satisfies your application through those metrics. Yeah.
So I'll make a prediction, and you feel free to disagree. I predict that this concept, I'm not sure if the term itself, I actually think the term is good because it's easy to understand.
Mhm.
I think the term may stick because it's something that the general public and regulators can easily understand, right? So uh, and then there'll be, I would say within the next 12 to 24 months, there will be people who are going to provide some sort of service where, you can, it'll help you with the unlearning step with the caveat that, I mean, like you said, there's no guarantees, it's not perfect, but at least now you get to the point where you're doing something, right? So kind of like fine tuning, right? So now I can fine tune. Now, is this a fine-tuned model really the best possible model there is? Well, I don't know. Maybe if I add more data, it'll get better and better over time, right? So
Yeah.
same thing with unlearning probably, right? So I can go to a service, I can do some unlearning. It's not perfect, but it's doing something. I can now tell someone, did you try? Yes, I tried. And then
Yeah.
and then you keep improving the unlearning over time, right?
Yeah. I think definitely I agree with that prediction in the sense that we have plenty of examples of companies, especially startups that claim certain things and then they serve certain products just because the term sounds cool, and then like people would like pay for that. I think that
Well, here the term
maybe.
not on
Mhm.
the term not only sounds cool, it's actually kind of very easy to understand and very clearly useful.
Yeah,
So,
I think that the use of heart may tie to the techniques, and obviously I was
yeah.
saying, as we were talking about these techniques, evaluations, and like kind of applications that you're thinking about. Um, I think that would definitely see people starting to like apply some of these techniques, but I think that based on kind of my understanding of the field right now, it's too early to really bake that into um um an application. I guess you can bake that into an application if you
Yeah,
have a very
it's not.
clear idea.
I guess what I'm proposing is it's not a. It's just another step that you do before you deploy,
Yeah,
and with the caveat that okay, so it's not a perfect thing that you've done,
yeah,
but nothing in the space can is 100% with what guarantees anyway, right? So
yeah,
you did
that's
something, and then before you weren't doing any unlearning at all, right? So it
yeah. You could we can definitely imagine a startup that starts selling Unlearning as a service where they just provide prompt templates that are really, really good at
yeah,
filtering,
yeah.
big model outputs. That could be possible. And it just as scientists, like we try to make sure that like we make accurate claims of what
Right.
you can and cannot do. At this point, there's a lot of things that it cannot do, and there's a risk of giving false promises to, I think, regulators.
It becomes
Yeah.
kind of part of the model development life cycle, right? So you go pre-train, fine-tune, test, unlearn, so on and so forth, right? So, and then you deploy. Now, not, the testing and the unlearning, you never know if you've done enough.
Yeah.
Unlearning in particular is probably the one where you probably are more likely to have missed a bunch of things, but you did something before you were doing nothing, right? So
Yeah, yeah, indeed. I think what you describe as the pipeline definitely makes sense. There are rumors that even says that, you know, I mean, obviously don't quote me on this, but like Llama 3 is for 400 billion has already finished training, but then they are seeing some capabilities that are not desirable and they try to like unlearn it. But then you could say that the same unlearning is just like fine tuning, like guardrails and like more RHF. So I think at the end of the day, terms are terms and they point to certain things that you do to the model. And it's useful and kind of important to just be clear about what exactly we're doing. Because if it's just fine tuning, you know, like unlearning could be like unnecessarily catchy term for that application.
and
Yeah.
the reason I kind of am making this prediction partly, Ken,
Uh-huh.
is because your article became so popular. And so that, to me, that tells me that there's interest and kind of, interest and there will be users of such a tool, right? So
Yeah, for sure, for sure. On the popularity side, I definitely did not expect this amount of attention for this. It's mostly just like a blog post summarizing my understanding of the field. Yeah, but people liked it. I'm glad.
so what's next for you? Are you going to do more unlearning?
Uh, I am working on some projects related to Unlearning.
Oh,
I won't be able to share that just yet.
yeah.
But yeah, this is something I will continue to think about. And I think I'm hoping to see more progress in the area. And in fact, I think ICML, sorry, I cleared ICML this year. We already seeing some submissions and papers on Unlearning that are looking interesting. So people are definitely spending a lot of effort right now.
Very cool. So one last question on the prediction side. So, RLHF, right? So became
Mhm,
popular.
mhm.
Do you think uh, uh, unlearning will reach that level of popularity?
I don't think so. This is hard to predict
Yeah,
because
yeah.
because part of the unlearning,
Part of it is you have to come up with the science has to be better.
yeah, the science has to be
But
better.
but
It's not
but,
as
but
sound. Yeah,
conceptually, people will want it if you get it to the point where,
yeah.
yeah,
And also, I guess there has been a trend where people would want things. Um, people want like capabilities. People would want
yeah, yeah.
this
In
model
that
doing
case,
fancy stuff.
yeah, yeah. In that case, it's preference alignment, so people know that
Yeah,
that'd be great to have, and this is one technique for doing that. So in the
yeah.
case of unlearning, we have the concept. Now we have to have the techniques to back it up, right?
Yeah. I guess what I'm saying is it's been unusual to my understanding that people would actively try to remove certain things. Like they would want to remove things more than they want something new. Um, so on that's I guess on that from that angle, it's hard to imagine that because RSA can give you so much. It can give you like a lot of things. It's not just preference. I guess it is preference at the end of the day, but the same preference learning can make models sound more like a maybe an anime character can make
Mhm.
it like sound like this and be a harmless helpful assistant can be like all sorts of things. Whereas on learning is like you know it makes the model weaker and people don't like weaker things, I guess, in that sense. So again, it's really hard to predict. I just think
Yeah.
that it's not quite there yet as a concept of unlearning. It needs to be built more upon to for us to make that prediction.
All right. And with that, thank you, Ken.
Thank you so much, man, for having me.